Hello and welcome to another video. We want to talk about the stack pointer today, but we also want to understand how link register and program counter can work together with the stack pointer to implement function calls in the assembly language. So I've got a bunch of lines of code here. I would straight away head into the debugger. I've set up the breakpoints and I'll go over them one by one as we talk this along. So notice right away that I have a breakpoint set up on uh, R1. We're just moving the value of 1 here. Let's just pass through it. Okay. And then the sequence of code takes us into func1, the function 1, right? And that's where, and we are executing this sequentially. So let's go ahead and do this also. We moved 2 in register R2. And now that we are here, notice this command. Now, this is something familiar, which is branch and link. So BL lets you branch and link to function 2, func2, right? And func2 is defined right here. So what you should expect from this point onwards is that you branch and you link to func2, and then this sequence of code, lines 12, 13, and 14, are going to get executed. You don't move 3 in R3, right? Because you're branching right away in line 8. So once we do this, what I also want you to take into account what happens when you do this. Have a look at what happens on this on your link register. So let's go ahead and do this, and there it is. Now, as soon as we did this branch and link to func2, notice the value in the link register is 389. Now this is an interesting value. We'll see for a moment why. For that, I have to get into the disassembly window, and the disassembly window, and I'll just scroll just a little up to see what's really happened. Now, from one of the previous videos, when you use the branch and link command, what it really does is it stores in your link register the address of the command that comes right after it. So this is a way for your processor to know basically what line to execute next when you come back from func2. So that way, you would then be able to execute this line number 9, which is moving 3 in R3, right? And this is where the register address also makes sense. So C link register has 3 and 9, which is in a sense the address where move R3 is set up. So that's the address for this instruction. We have already talked about this in the previous video, why this is 388 and why this is 389, and there's a difference of 1. That is basically indicating that the processor is in a thumb state, with the least significant bit indicating that when it's set to 1. So that's why it has 389. There's a difference, 388 and 389, but this is essentially the address for the instruction which moves 3 in register R3. So that's something that's happened when you do BL func2, branch and link to function 2, the link register has the address to this. But what happens next is also interesting. Understand what we're doing here. So from the previous video, we learned the functionality of stack pointer and how stacks are implemented. So here we're pushing link register in the stack, right? So this is basically link register has the contents of the link register have the instruction address for line 9. That gets pushed into the stack. Okay, let's push it into the stack, and that's fine. But remember, when you move something into stack, it's supposed to decrement in value, which is why it becomes 1FC from 200. Uh, Please refer to the previous video how these decrements happen in 4 bytes, but we've seen how stack has been pushed once and it contains the address or the contents of link register. Now we're moving 4 in R4, and that's fairly straightforward. We see 4 in R4, and that's fine. But now when we pop the stack, essentially we're popping the contents of the link register and we're popping them into the program counter, and program counter always stores the address of the next instruction. And in this case, the contents that are going to get popped into the program counter are in fact the contents of the link register, because that is what was in the stack. and link register contains the address of instruction 9, right? So when we pop the stack content into program counter, essentially we are popping the contents of link register, which is containing the address of line 9. So let's go ahead and do that and see what happens. We've done this now, and we have arrived. Notice at instruction 9. That is what the program counter tells us. We are at 388. That's exactly the address of instruction 9, 388. Notice the stack has been popped, so it has incremented back to its original value of 200 now. The pop functionality has gone through, and we are here at line 9. And we can now store 3 in R3, and that's fine. And then we can branch to stop, and that ends the sequence of the code. So, as a summary, what's really been done in this specific code is we have learned how to go from one function, we were in func 1, into func 2, function 2. We can execute some things. These are just placeholders. These can be any instructions, the move instructions. So you could do some things. You could do a bunch of operations. You could go into a function, do a set of operations there, such as in line 13, and you could do multiple operations. But once you enter function 2 and exit function 2, you can use the stack. You can push and pop. You push contents of link register and pop the link register into the program counter. This is beautifully done because you have the branch and link. This is something that you use to get into function 2, which stores the address of the next instruction in the link register. This is why this is a super nice example where all the three registers are being used: stack pointer, the link register, and then the program counter. All three are being used in harmony to implement return from a function call. So you go into a function using the branch and link, and you come back from the function into the next instruction by making sure you're using a stack. I hope this makes sense. If there are any questions, happy to address them in the comments. Thank you.